Hello and welcome to Think Python, Chapter 3, Part 2. If you're just starting on this chapter, you can use that link to get to this page, and then click here to run Chapter 3 on Colab. But since I already started this chapter, I'm going to switch to this notebook, which contains the work that we did in the previous part. Picking up where we left off, variables and parameters are local, and let me explain what that means. When you create a variable inside a function, it only exists inside that function. So here's an example. I'm going to write a function that's called cat twice. And it's going to take two arguments, part 1 and part 2. Inside this function, I'm going to define a variable that's called cat that is equal to part 1 plus part 2, and remember that for strings, the plus operator does concatenation, so it'll join these two strings into a single string, and then I will call print twice to print that value twice. To call this function, I'm going to define line 1 as always look on the, and I'll put in a space, and then line 2 as bright side of life, and that's another reference to a Monty Python song. I'm going to call the function cat twice and pass these two strings as arguments. When I call that function, it concatenates the two parts together and then prints it twice. Now, the point of this example is to show that that variable cat, which is defined up here inside of the function cat twice, only exists inside the function. If I try to print the value of that variable from outside the function, I'll get an error message that says cat is not defined. One of the ways that we can see what's going on here is to use a stack diagram. In the previous chapter, we saw a state diagram that shows a variable and its value. A stack diagram shows each of the functions and their parameters and any local variables that are defined inside those functions. If you run the next two cells, you'll see code that creates a diagram and then draws that diagram. In this diagram, we see one frame for each function. So reading from bottom to the top, we see that print was called by print twice, which was called by cat twice, which was called in main. Main is the name of the topmost frame, so if you define a variable that's not inside a function, it's defined inside of main. And again, reading from the bottom to the top, we can see that print has a parameter that contains the string that gets printed, always look on the bright side of life. That question mark indicates that I don't know what the name of the parameter is inside of the print function. But inside the print twice function, we know that the parameter is named s, and its value is always look on the bright side of life. Going up one more frame, inside of cat twice there are two parameters, part 1 and part 2, and one variable that's defined inside of cat twice. So it's a local variable that only exists inside that function, called cat. And finally, at the top level, in main, we have the two variables, line 1 and line 2, that are defined outside of any function. We'll use stack diagrams as we go along as a way of understanding programs where one function calls another, which calls another. To demonstrate, I'll create a function that has a deliberate error in it. So I'll define a version of print twice that takes a parameter called string, and it's going to print that string twice, but instead of calling it string, I'm going to accidentally call it cat. So when I call this function, it will have an error, which is that the variable named cat is not defined inside this function. Now, before I do that, I'm going to call xmode verbose in order to tell Jupyter to give us detailed debugging information, including what's called the traceback. So now we have an incorrect version of print twice. And remember that when we call cat twice, it calls print twice. So I'll call cat twice with line 1 and line 2 as the arguments. And when I run this, I get an error message that shows me that cat is not defined inside of print twice. This output is called a traceback because it shows me the entire execution of the program from the place where the error occurred and up through the stack, through the frames that are on the stack, which I can open up to show here. The error occurred inside of print twice, and print twice was called by cat twice, and cat twice was called up here at the level of main. So there's a lot of information in a traceback, and it takes a while to get used to reading these. But what I hope you see in this example is the connection between the stack diagram, which shows each function calling the next one, and the traceback, which shows at the time when an error occurred, all of the functions that were running. So we'll stop there for now. In the next video, we'll work on some of the exercises.